Greetings, A-level chemists, year 12 and year 13. Here we've got an EZ isomerism type question. What we're going to do is, rather than looking at this condensed version, what we're going to do is draw out all of the bonds, okay? So, let's redraw this. Okay, so we've got CC double bond. Remember you've got restricted rotation around the CC double bond. Okay, I'll just explain. So you've got restricted rotation around that CC double bond, and you've got two different groups attached to the carbon, both carbons, where you have that CC double bond, okay? So that's what gives rise to the geometric isomerism. Okay, so let's draw out what we have. So you've got CH2, CH2, Cl, and we've got CH2, Cl. Right. Let's just look at this carbon of the CC double bond first, okay? So I'm just drawing a squiggly line just to separate the right-hand side and the left-hand side of my drawing. Now, this is Kahn-Ingold pre-log rules, and what we're going to do is we have to have a look at the atomic number, because the highest atomic number takes priority, okay? It's the atomic number, not the mass number here. So, directly attached to this carbon, we've got a carbon which has an atomic number of 6, and we've got a carbon also attached to the carbon of the CC double bond, which also has an atomic number of 6, okay? So we've got no difference there. So what we have to do is look along for the next point of difference. So we go up one, we've got a hydrogen attached, and we've got a hydrogen attached. So no difference there as well. We go down one, we've got a hydrogen attached and a hydrogen attached, no difference there as well. However, if we go along, we now have a carbon attached there, which has an atomic number of 6, but we've also got a chlorine on the bottom one, which has an atomic number of 17. Well, 17 is greater than 6, and this group at the bottom is going to take priority, okay? So that's going to be your priority group, and let's circle it. Okay, so we've done the right-hand side of the molecule. Let's have a look at the left-hand side of the molecule. So, got CH2, CH3, okay, and at the top we've got CH2, OH. Okay, so let's have a look for points of difference. So you've got an atomic number of 6 here and an atomic number of 6 here, no difference. You've got hydrogen there, no difference. Hydrogen there, no difference. Okay, if we go along one, we've got a carbon here, which has an atomic number of 6. If you go along one here, we've got oxygen, which has an atomic number of 8. So 8 wins over 6. So this is going to be your priority group. So is this the E isomer or the Z isomer? Well, you can see that the priority groups circled in red are on opposite sides. So this is going to be the E isomer. Okay, let's have a look at another one. So let's draw a squiggly line separating the two carbon atoms where the CC double bond is. So we're going to have a look at the left-hand side and the right-hand side. Let's have a look at the left-hand side first. So directly attached to this carbon of the CC double bond, you've got a carbon which has an atomic number of 6. And directly attached to on the top, you've got a chlorine which has an atomic number of 17. So 17 is greater than 6. So the chlorine takes priority using our Kahn-Ingold pre-log rules. Okay, let's have a look on the right-hand side. So you've got a carbon attached and a carbon attached at the top and the bottom. That has an atomic number of 6, and that has an atomic number of 6. Okay, so no difference there. So if you go at the top and at the bottom, you've got some hydrogens, and at the right, you've also got a hydrogen at the top, which all have an atomic number of 1. At the top, you've got a hydrogen here. At the bottom, you've got a hydrogen here. However, if you go to the right, you've got an oxygen, whereas at the top, you've got a hydrogen. So this has an atomic number of 8, and all of these have an atomic number of 1. And just to show that, I'll draw it. So 1, 1, 1. So here you've got OH. So we're comparing this point of difference with this point of difference, and that has an atomic number of 8. So 8 is bigger than 1. This then becomes your priority group. You can see that they're on opposite sides of each other, so this is also going to be the E isomer. Thank you for watching. Ta-ta.